Okay, so this is the teaching demo for the Chance Lab, and with this lab, it's kind of fun for the students because they get to play roulette, do a little gambling, and so when you introduce the lab, you want to tie into lecture that in lecture in the next week or two, Dr. Elser is going to be introducing probability to you. And he's going to take you on a little road trip to Vegas in the lecture, and so you're going to get a touch of that here in lab today. Okay? So this lab is about chance, it's about probabilities, and how we apply probabilities to the biological world of science. And the first thing that we want to touch on is probability. So what is probability? Okay? And hopefully somebody will give you an idea of what probability is. But probability is the likelihood an event will occur. Okay? So what's the likelihood the Cardinals are going to win the game this Sunday? Or what's the probability that our football team, the ASU Sun Devils, will win the ASU U of A game this year? What's the probability of that? Okay? So, probabilities are the likelihood an event will occur. So how do we calculate probabilities? How do we do that? Well, we can calculate probabilities or probable outcomes by taking the number of chances that the event has and divide that by the number of opportunities. Okay, the number of opportunities. So, for example, what's the probability that Shinio Kyo is going to make a free throw shot? Okay. Well, you would take the number of chances divided by his number of opportunities. Okay. So his number of chances to shoot a free throw shot divided by the number of opportunities. So that's just an example there. So if we wanted to calculate the probability of any event to occur, then we take the number of chances the event does occur divided by its number of opportunities. And that is how we can calculate probabilities. Okay? And with probabilities, you know, in science we like to use quantitative data. So we express them as ratios. And these ratios we calculate again by taking the number of chances divided by the number of opportunities that an event will occur. And so that's what you guys are going to be working on today. Is you're going to have 3 stations that you're going to go around to. Okay, so you're going to spend 20 minutes at these 3 stations, and I'll float around in between to see if you need any help. And then I'll have a little, you know, I'll time you at about, you know, I'll tell you, okay, you got a few minutes left at the station before we rotate. Okay? So here's what the 3 stations are going to be at the different tables. The first station, or one of the stations, is you're going to roll some dice. Okay, so at station 1, the students roll a dice. Okay, and there's a chart in your lab where you will record the data for your dice rolls. And you're actually going to record the sums, okay, the sums. And so the first thing that they're going to roll dice, and they're going to record the sum. So the first time it tells them to roll the dice 10 times and record the sum of those rolls. So if they roll the dice and it comes up 1 and 1, that's a sum of 2. So they would put a little check mark or for the sum of 2. So they roll the dice 10 times and they record that data. Then they roll them 40 more times, record that data, and then they roll them 50 more times and record that data, those sums. So they're rolling the dice 100 times, okay? And then they're supposed to graph add all 3 columns together, so it'll be 100 rolls total, and they record on the board the data for 100 rolls, okay? And when they do that, and at the end, then we'll discuss. So, whatever station they start off with, the dice rolling station, they roll those dice and they graph the sums on the board. Okay. The other station that they will be doing is flipping coins. Okay, and in the student lab, there is a portion for them to record their flipping the dice. Okay, So they're going to flip a die, or I'm sorry, flip a coin. Okay, so the coin either is heads or tails. And they're going to flip the coin, and they're going to record those results, and they record those results in their student lab manual where it says actual data. Okay, and so that's here. It says flip a coin 100 times and record whether each flip comes up heads or tails. So they flip H, flip T, flip H. So they record that 100 times. Then what they're supposed to do is they're going to do imaginary data for flipping a coin. So they're going to, with their partner, call out imaginary outcomes, heads or tails, 100 times. So basically, you know, heads, heads, tails, tails. If they were flipping a coin, then they're imagining what the data would be. So they do that, okay? And then they're supposed to, after they get that done, record that data on the board in a graph as well, okay? And then the roulette station, there'll be 2 roulette wheels set up in the room at the tables, because again, you'll ask them to rotate, okay? So they play roulette for 20 minutes, okay? And the rules for roulette are listed. They'll be taped on the table for the students, okay? So one of them has to act as the dealer. There'll be chips. They start off with 30 chips. They'll place bets, okay, on the roulette pad, and then whoop, spin and play roulette, okay? And we have a handout for the payouts, okay, at each table here, the roulette payouts to winners, and that explains to them how to pay out if they, you know, win at roulette, okay? And so for the roulette, they're just supposed to kind of take notes on that. We don't have anything for them to officially graph or anything like that on the board. Okay? So then you release them. You know, to do this, and they spend 20 minutes, and then you switch, 20 minutes, and you switch. And then you do the discussion at the end. Okay? And so the discussion at the end, you look at examples of data that are on the board. So if we go ahead and go start with I'm going to erase this, okay? If you go ahead and start with the dice, okay? And so the dice graphs should look something like this, okay? So they should have the sums, which go from 2 to 12, right? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then this are the number of rolls, okay? So what should the graph look like? Okay, the graphs hopefully should take on this pattern, right? A nice bell-shaped curve, okay? So they either do dots or they could do bars, okay? But their graphs, okay, should look something like this. And you want to ask them, all right, so let's look at all the graphs for the rolling the dice and their sums. And what do we see? Do we see any patterns? And hopefully they should say, yeah, they all take on this shape right here. Okay, this like bell-shaped curve. So we can call that a bell-shaped curve. Okay, or you can call it normal distribution.